some goodies arrived for this old PP5150 with a bad output transformer, which is stock one's right there. The new one looks physically smaller, but it's absolutely high quality. This is a Hammond 1760W. It is a replacement for a twin reverb. As far as the watts go, as far as the primary and secondaries go, it is almost a direct match, and it should actually be a higher quality transformer than the stock one, which, to be fair, did die. Though in speaking to the owner, he bought this used, and the previous guy had been using it with a load box, apparently an awful lot. And load boxes are not all created equal. And some of them love to kill, guess what? Output transformers. So, there's some really good ones on the market. There's some really bad ones on the market. There's so many and I don't really have a use for them myself, that I don't keep up with it. I would say that, the UA aux box, the SIR reactive load, there are some really great ones out there that are probably not going to hurt your amp, but there are a lot of cheap ones that will, and a lot of guys will just run the effects out into some computer interface and not plug anything into the speakers, and it'll work for a while, and then this kind of stuff happens. So I don't know what exactly went wrong, but something did go wrong. And while replacing this, we're also going to change out the 2 input jacks, because the original ones are, they're flimsy to begin with, and the original ones are just flexing an awful lot. In order to put in this bad boy, I've got to take everything out to have access. While electronically, this is going to be a pretty much one-to-one drop-in. Mechanically, I'm sure the locator holes are in different places, so I'll probably have to do some drilling and cussing. I had considered doing this as my first ever live stream, but I think this one is going to be flipping the chassis around a lot, and big periods of taking measurements and transferring measurements and drilling. Drilling is not fun for you guys to listen to, and I don't have an overhead boom that would get the whole thing. So I'm just going to do this one my traditional way. But I do have an amp in the queue. I think I might do a live stream on that amp, maybe Tuesday or Wednesday. More on that to follow. Let me get everything out of the 5150 so we can access this area and get started. Here comes the exciting part. Hear that click? That was something cracking on the board. I don't know whether it was the old jack or the solder joint. But those plastic jacks really don't handle any torque very well. And the fun with all these tiny little nuts. You've got tiny little nuts. Some of the knobs come off if you look at them hard. Some of them don't want to move. Please, please, please don't let someone have glued them in place. We see that all too often. Actually, what happened is not glue, fortunately. The ones which were coming off easily, the splines are too compressed. You can see it here on this low. And the ones where they didn't want to come off at all, the splines were not compressed. Now, these splines, when they're compressed like this, I will try to open them back up. The trouble is, this metal is cheap. It is pressed, made from compressed powdered metal. It has no real tensile strength compared to steel or brass or even aluminum, believe it or not. And so it's very possible to break things when you do this. So I'm going very slowly, and I'm doing it now so that if I break one, or if one is broken, when I have the board pulled, that's the time to replace that pot. There are times when I watch myself talking to myself while doing these videos, and I think, what a weird world this is. A, this is a job. B, that people want to watch it. All right, now that that's, none of them broke, so those will all hold on to the knobs in the future. Behind the knobs, a lot of loose nuts. Yeah, they're turning by hand, most of them. Well, at least I won't have to break out the big tools to get these off, though I'll use the proper socket to put them back in place. I mentioned in the first or the previous video on this amp, I don't remember how many I've done now, that I suspect one or more broken solder joints on these pots. And with these nuts being loose, that would explain that, because there'd be no support for these pots. And the mechanical stresses that occur to them as you use them, where things bump into the amp, except for the solder joints on the board. These nuts are important. If you own a 5150, or most amps actually, it's not a bad idea, especially with amps with push-on knobs like this, once a year or more, up to you. Take the knobs off, make sure all the nuts are tight and that nothing is vibrated loose, because it really will cause big problems down the road for you. I was watching my buddy Brad Webb do a 5150 the other day, and all his ribbon cables were really loose and they just popped right off, no problem. And I was feeling kind of jealous, because usually these things are a bit of a pain to get off without, you don't want to pull on the ribbon itself, you want to pull on the connector, because otherwise you'll break a wire. And they're usually pretty stubborn. This one right here feels like it's going to be a pain. Sometimes I'll get a flathead screwdriver and see if I can use it to lever them out, at least get them started. Again, like on the pot shafts, not a whole lot of force applied at once in any one area. I don't want to bend everything. I just want to start the separation. And sometimes that's not enough. The trouble is, this board itself is pretty flimsy, so I don't want to put too much pressure using it as a lever fulcrum point. There it goes. His were all loose, and as a result, were full of corrosion, and he did a very good job showing how to clean all the pins and contacts and all that. Mine are all shiny and new because they were on there so tight that I had that problem. I'm going to put the preamp tubes to the side. Let's see here, which screwdriver will fit that. Next one down. When I put the tubes back in place, I will experiment to see which positions, or if any, are quieter than others or less prone to microphonics. There are certain stages in the 5150 where noise is, any noise variation within the tube is amplified, and same for microphonics, etc. Now, something I've been wondering about on the 5150, sorry, I tried to start this one left-handed, is this frame, this bracket, which is isolated, mounted from everything else that the board screws into. If you touch it with your fingers, well, all the noise in the amp increases. Come on. You want to come out. You want to come out. You know you do. And it's not connected to any ground on the board. And it's isolated. Can you see this? It's isolated from the chassis by these rubber grommets. I'm wondering if I were to ground it, each one to chassis, with a little bit of wire and a strap, whether that would affect noise. Let me verify that that's not already grounded to chassis. I don't think it is, because it gets noisy when I touch it. So it's acting like an antenna. No, I think if these were grounded, might be actual a little bit of shielding. May not make any difference. Anyway, let me get some other stuff disconnected. All right, that's everything but these and the screws. So let me pull these out. Disconnect that just to get out of the way. All right, I'll spare you the excitement of watching me remove little bitty black screws. I think you can guess what I'm about to do, and we'll pick up again afterwards. All right, now this should just lift up and out. Now this front panel is all flapping around, And if I move this to the side to get it out of our way while we look at the preamp board and stuff, there's just a risk that I'm going to hit this at some point, or it's going to get someone's going to hit it, it's going to get a bend in it, and it's hard to get that out. So I'm going to give it a quick clean, and then I'm going to tape it in place just so that it can't get any damage. And I'm not going to use any solvent to clean it. I'm just really going to... There are some different panels out there that you can actually clean. Old Marshall metal panels do not even breathe too hard on because the moisture in your breath will make the ink come off. Some stuff is laser revealed aluminum arc, and it's hard to mess that up. I can feel that this is ink on a metal, and I don't want to find out the hard way that even WD-40 takes that off. So I'm just going to give it a wipe. It's going to look as good as it looks. I'm not here to be Martha Stewart, but I'm not here to damage anything either. So just give it that little bit of blue painter's tape. Now I'll put the chassis to the side. All right, I've done a pretty good visual inspection of all this. I don't see any completely broken solder joints, but I see most of the pot connections have those little semicircles and circles around them as if the break is beginning or is minor, but there's no such thing really as a minor solder break, and it will just get worse. The nice thing about this era of PV is that they use leaded solder, so I don't have to remove all the old stuff. I can just add some fresh, and I'm going to change up those 2 input jacks, and then grab some lunch and come back and give it another visual inspection with fresh eyes to make sure I didn't miss anything. So that won't take very long. All right, all the pots have been reflowed. All the jack and switches. The jack's been changed out, some shiny new ones. This is the same jack they use on the Fender reissues, by the way. Switches have been reflowed. Nothing else looked like it had any problems. All the pots and switches have been cleaned with deoxit, and I hit the board with some alcohol and my toothbrush to get any flux off. Let that all evaporate. I put some deoxit down into the switches, operated them a few times. The pots are all clean. Hopefully everything will be good to go. I'd said I was going to grab lunch in between these stages, but then I thought about my time management a bit better. And I got to this point. Now I'm going to have lunch, and then it's time for transformer replacement, because I needed to be well nourished before tackling that. All right, the first issue of getting this old output transformer out is that they have these Molex connectors, whatever you call them, and they run the wire through this hole, and then they attach these connectors. And there are specialized tools to install new wire, remove and install wires in these. Those tools cost a lot, and those connections aren't that good anyway, so I'm going to redo them the old-fashioned way. So these just get snipped out. I'll suss out which wires go where on the impedance connections, and I know which wires go where on the primary connections. So these are the primaries, these are the secondaries. But now that those ends are off, I can remove these wires through this hole, and let me detach these 4 screws first. Let's see. All right, I will not be reusing these 4. Any guesses where the old transformer was? Let's get that all cleaned off. That makes me feel better. All right, so this is where the wires will feed through. Here's the new transformer, and it is on the same angle the old one was at. The issue is the holes that mount up. If I can get 2 to reuse, that would make my life easier. I don't think that's going to be possible. And there's this rivet here, which limits some of my abilities. So I need to find a place where it will sit flat, whether I can use any of the old holes or not. All right, that's about where it's going to go. So I can't reuse any of the old holes. Why is it rocking? Is there something in between? Okay, it's rocking a little bit because the brackets were not attached evenly by Hammond. So what I will do is first I will use this to locate where the holes are going to go. And then I will loosen these so the brackets can be flushed up against the chassis. So nothing's going to be having so much torque on it to force a bend or anything. And then these will get retightened up. So, it's a two-step process. So I need to put some of that wonderful blue tape on the chassis. Let's get it to eyeball up where it needs to be. That's pretty good. I'm not worried about which side goes where yet as far as the wire lengths. I'll sort that out in a moment. All right, so that's pretty good. What I want to do right now is get a pen and mark my center lines. That's good. Move this to the side for a moment. Then, if possible, get a right angle to the chassis at each one of those lines. It can be a little bit complicated based on the little bits of rivet and stuff floating around. And just draw that same line out. And that'll give you a straight line from the chassis. Do the same thing here. It's a little bit hard to see with the shadow. Now, let me mark where I want my centers to be on the other axis. That looks pretty good vis-a-vis the chassis. So here. Here. It's a bit hard to do on this surface because of the screws. But again, there's going to be a slight margin of error due to the hole size. So that gives me my 4 drilling locations. I'm going to spare you the sound that all this is going to make, drilling into steel. But I'll tell you the principles behind it. I'm going to use some number 8 screws to do this, which will give me a good secure connection. I'm going to start with a very small bit to do a pilot hole. Well, it's a bit smaller than this, but this was the first small one I found. Once that pilot hole is there, I will then open it up to 1/8 of an inch. And then for number 6, I would take that up to 9/64, but in this case, I'm just going to use the step bit to go to, the step bit's so worn I can't see it anymore. Anyway, the third one, give me a nice bit of slack. This is a steel chassis, so anyway, basically I want to make sure the number 8 screw fits in there. And I'll show you a crucial step on drilling steel before we start to drill. Before going in there with the drill bit, at each of these, I'll take my nail set and give it a good tap. That way the bit will have a little thing to dig into and the bit won't go wandering all over the place. It'll stay centered. And then when we get all these holes opened up, then I'll show you the next crucial step you have to do on these things. And now we have 4 evenly spaced, very neat looking holes in the steel, right? We do from this side. Let's look at the other side though. The other side shows 4 very jagged holes with little shards of metal. You can go in there with a deburring tool. You can go in there with a countersink bit. In this case, I'll just use the drill from this side because there's a little bit of a countersink edge to the next hole size up. Should clean this up just fine. That all feels good. Let me get rid of that debris and then we'll start mounting this. Here I've loosened the 2 nuts on either side of the bottom so the flanges have a little bit of movement so I can get this thing flush. Now the next thing I need to do is look at wire length. Here are the secondaries and they won't quite reach to where they need to go in that orientation. So they probably need to go over here.
People ask, what's the proper orientation for these things? There is one, but sometimes you go with what works. Next, we have the primaries, which the center tap's going to be long enough. I'm not entirely sure of the others. Hammond cut these links to work with most twin reverbs. I'm sure it's fine for a twin reverb. It's a little bit short on this. If I need to extend the primaries, I can do that. The important thing is for me to bring it into the chassis safely. Let's see, maybe if I go underneath like this, it'll buy me the space I need. That ought to do. Yeah, that'll get me there. All right, so this is the orientation it's going to have, because I can't pass the secondaries beneath it from the other side. They're too thick. So this will work. It's a little bit of a compromise, and that sometimes I like to separate primaries and secondaries a little bit. Not really possible here, but then again, PV didn't separate them. They ran them through this one hole anyway. So it's not about what I would do if designing it. It's about how the amp is. Let me get some mounting hardware together. All right, so the way it's going to go is I got a stainless steel number 8 machine screw. Got a stainless steel lock washer, then a stainless steel washer. And if I do it without this washer, then that compression lock washer will tear into the surface of this flange unevenly. If I do it without the lock washer, things could back out. Between the lock washer up top and a nylock nut beneath, also stainless, this should not go anywhere. So I'm going to get started by hand. Then it's a matter of tightening it up. All right, when we do the other 3, then we'll tighten it all up. All right, now all 4 are in, nice and tight. And see how the transformer moves? It's because I loosened these brackets. So these brackets would flush up against the chassis without anything being stressed. Now I'll just tighten those back up. We'll do the same thing for the top ones, just in case. And before I flip it around, I'll check the 2 on the power transformer, the old stock power transformer. In just a moment, we're going to show how to turn this into a neatly wired, reliable amp. All right, it's all back together with the original tubes, and I cleaned all the tube sockets and all that fun stuff. You can see I've got the headers gone, and these are soldered to the pins with some heat shrink to keep them from touching each other should anything go crazy. You can see I've got this external jack. Both these original jacks were a little bit intermittent. Until the amp was putting out full power, I couldn't verify, there's no way for me to know that. But now, the amp's noisy, but it's working at full volume. I'm not playing at full volume here for this clip because of the mic that I use for these videos. The voiceover would freak out, but... That's working. I've got some hum that I did not have a minute ago with my test set of tubes, so I think the 6L6s took a beating from the previous operation when they had the failing screen grid resistors, so not all the tubes were actually operating. So we have an uneven current draw. I think this would benefit from 4 new 6L6s, and the Sovtech LPS preamp tubes aren't extraordinarily noisy, but they are a little bit noisy in microphonics. So I'm going to see if there's a minimal number of preamp tubes that could be changed to improve the background noise. Because I'm on the clean channel at the cleanest setting, and it's still a little bit noisy even for a 5150. So I'm not done, but I have full volume again, and that's a nice place to be. I'm not sure if I'm going to replace the output jacks with the exact type that used to be in there, which are pretty crappy, or put some Switchcraft 12As, which are higher quality, and from the outside they'll look the same, but the new ones will not fail ever. That's an easy thing to get to later. First I'm going to chase preamp tubes and all that fun stuff, But I think I'm going to do that tomorrow morning because I have other stuff to do today, and this is a good place to stop. I know that I have slain the biggest dragon. Now I just have a few normal day-to-day gremlins to deal with.